If an object has been enlarged or reduced, you can tell by the scale factor. Okay, so enlarged, E-N-L-A-R-G-E-D, or reduced, R-E-D-U-C-E-D. Enlargements have a scale factor that's larger than 1. So numbers, for example, are larger than 1 would be 2, 1.3, 5 over 4. Those are all examples of numbers that are larger than 1. Notice a fraction can be larger than 1 if it is what kind of fraction? Improper. So the top number, the numerator, 5, is larger than the denominator, 4. Okay. What happens when we have scale factors or shapes that are large is that the shape hasn't changed, but the size has increased. So a triangle is still going to be a triangle, just larger. If it's an isosceles, it'll still continue to be an isosceles. Okay? If you have a rectangle, if you enlarge it, it'll just be a larger rectangle. It doesn't become a square. To calculate your scale factor, you'll take your new image measurement and divide it by your original image measurement. So you might have to use your ruler to get that measurement. You'll have to measure things in your textbook when you're doing your homework. Okay? So let's practice that. We have 2 lines. We're going to measure them in inches. So please use your ruler, measure in inches, see what you get. Some rulers I know don't have inches. That's okay.
Oh my God.
So right, A is 1 inch and B is 2 inches. Okay. So what do you notice? What can you say just by looking at the numbers right away? Kezia? Good. B is twice A. But what if you looked at it the other way around? What can you say?
1 inch.
A is half B. So that's really interesting. Because you have the same diagram, same line, depends on what you look at as your new image and what's your original image. So if we switch them, you get a completely opposite scale factor. So you got to be careful. Okay? Now what we're going to say is we're going from line A. That means it is the original. You have to read the sentence carefully. To line B means it is the new image. So for your scale factor, SF, that equals new over original, equals line B measurement of 2 inches over line A's measurement of 1 inch. Your units will cancel, they'll divide to 1, and so we're left with 2 divided by 1, which is simply a number 2. So our scale factor would be 2 going from line A to line B, which makes sense because we said B is twice A. Okay. Reading will be half the issue here, this unit. Now scale factors are less than 1, those will be reductions. Okay. Numbers that are less than 1 would be 0.8, 2/3, 5 over 7. Any kind of proper fraction or decimal that is less than 1. Okay. Again, the shape hasn't changed, but the size has reduced. Okay. So I want you to measure the height and width of the triangles A and B. So find the height, find the width, height, and the width. Go. Okay, top, what is this one?
2 inches.
This one?
1 inch.
Okay, this one?
1, half. And then the one besides half an inch, but I don't really know how to. You just write half.
Give it a half. You can also put 0.5, although you shouldn't use decimals with metric. But according to my brother-in-law, he says they do that all the time. So be it.
What, is he American?
Yeah, he's American.
Are you American?
Nope.
What up?
Okay. Good. So we measured that. What do you guys notice now about A and B?
Double the size.
Dustin?
Okay.
One's half the size of the other.
Which one? Is A half of B? B is half of A. And if you switched it around, you could say A is
Twice as big.
twice B. So you got to pay attention to what we're starting with. Okay, so scale factor going from image A to image B. So from, what does that make image A? New or original? Okay, because if you're starting at A, that means it's the original. And if you're going to image B, that makes it the new image. Okay, so the keywords are from and to. From and to. So let's look at our scale factor using our measurements. New over original. What number do you want to pick from image A? Well, the 2. So 2 over 1, which equals 0.5. It's okay for decimals for this unit, for this scale factors, okay? Or you could also, of course, go 1 divided by 0.5, which still equals 0.5. Sorry, I got that wrong. 0.5 divided by 1.
Oh my goodness, I wrote.
Hold up, stand by 1. Mr. Barker needs a calculator.
Okay, wait, what do we do? Oh my goodness gracious.
Image B. Let me think.
What are you doing?
Image B. Image B number should be 1 over 2. So it is 1/2. Haha. Or we go 0.5 divided by 1, which is still 1/2. Okay. And going to the decimal is probably going to be easy to work with this unit. Okay.
Oh.
Now we're all right. I had my new and my original messed up. See how important it is? That was just to demonstrate. Okay. What about going the other way? Okay, so now for your scale factor, new over original. Now your new is 2, your original is 1, scale factor of 2. Or it would be 1 over 0.5, which again gives you a scale factor of 2. Okay, but what's important is that you're lining up 2 and 1 and 1/2 and 1. You don't want to cross them because what does the yellow make? A wrong answer. See? Ha ha ha. Okay.
What's the point? What? Oh, get it. I got it. Got it.
Thank you. I like that. Bonus marks. Okay. Good. So what are some images that are good? So what devices are great at enlarging images, making small things bigger? Magnifying glass. What else? Surgery? Really?
Can you guys get it? Bonus marks. I like making things fun.
Okay. What devices are good at making things? Glasses. Good. What else? Yeah, contacts. What else? Oh, come on. What did the early sailors use?
Binoculars.
Telescope. Binoculars.
Oh, yeah. No, it's not working. Oh, okay.
Good. What else? What's the most famous telescope?
Hubble.
Hubble. Thank you.
How do you know that? What?
Who doesn't know that?
Hubble?
Hubble telescope.
What's that? Is that the...
Are you not Canadian? You should go to another country. So, yes, sir.
Alright, I'll go here. You better one.
Oh, computer, would it just enlarge? It totally can. Or it can also reduce. Okay? Yeah, computer, printer, Okay. Now, reducing, of course, would be computer again. We just talked about that. Or printer. Camera. Binoculars.
Binoculars?
Pardon?
Binoculars.
Yeah.
You said something totally different. Or
Telescope?
you heard totally something different. What were you?
Glasses.
So confused. We have glasses. Oh.
They can do both. Depends on what type, right?
Oh, yeah.
Yeah, they all work that way. Wait, any questions? Pardon? Little things in the holes. Oh, right. Peepholes.
Peak holes.
That would be enlarging or reducing?
Enlarged.
Yeah.
Yeah.
No.
Yeah. It's a. You basically see the
Hold on. Is it just the face?
kind of. Yeah, it enlarges
Oh,
the face so you can see it.
Oh, it enlarges it. So it takes my face and that little peephole, it makes it bigger?
Yeah. It actually does.
Really? It makes it
No,
bigger.
it doesn't actually make your face bigger.
So really, since my big face can fit in a small peephole, what would it be?
No, reducing. Why? Yeah.
Okay, good. Okay, that's enough going on. Reductions, enlargements. For a scale factor, what kind of scale factor gives you a reduction? Less than 1. So you're going to be between 0 and 1. Again, some examples would be 2/3, 5/7, 0.8, etc., etc. If it's neither a reduction or enlargement, then your scale factor equals 1. If it's an enlargement, greater than 1. So 1.1, 7/3, 5/2, those are all enlargements. Okay. Good, now we're going to practice drawing them. So the first thing you want to do is measure the objects. Oh, look, we're so nice, it's done for you. Then you want to multiply by the scale factor, underline multiply, to get the new measurements. Yes, Kezia? Negative numbers, what would a negative measurement look like? Do you see any negative measurements on your ruler? So that's why we're always dealing with positives, because we're dealing with measurements. Okay? So in order to switch it around, you'd think of dividing, multiplying and dividing, okay? But really what we do, Kezia, is we flip our scale factor. So if we have a scale factor of 4, then if we want to do the opposite, it'd be 1/4. That's something we're not going to go into too much, though, okay? Good. So 3 times 1.5, what does that equal?
I'm just saying it's based on height, right? We're kind of being.
What we're trying to do is figure out what our new measurement is. Based on a scale factor of 1.5. If we wanted to find the area, absolutely. Are you talking about length and width? Or?
I don't even know what I'm talking about.
Neither do we.
Teaching.
Okay. Sounds good to me. So this would be 4.5. And 2 times 1.5, what would this new measurement be? 3. Good, so please use your ruler and draw a diagram with those measurements. Go. You're actually going to use your ruler and draw a diagram with those measurements. Right here.
Oh, that's not fair.
Oh,
That's so not fair.
oh, quit your whining.
Can I have a ruler? I'll give you my shoe.
No. There we go.
Oh, we're using inches, aren't we?
No. Arjun, what's the new measurements? How'd you get them? What'd you write down? Look on your work.
I know. 0.5.
So for the next shape, you should have another rectangle. It doesn't change, it doesn't become a triangle. But now you're going to have 1.5 centimeters up top and 1 centimeters for the height. Good. So you have to do this for some of your questions. You have to do 3 steps. Measure, multiply, draw. Okay. Any questions?
No.
Turn it over.
Well done. That's done. Just wait, brown. I like.
Okay, so the next method is to use grid paper. And what we're going to do, use different size grid paper. If you'll turn it over, you'll see, guess what? I have some for you.
Oh, thank you.
You're welcome. Hey, Christmas is coming up. Just remember, I like chocolates and other presents.
Oh, wait.
Just a joke, by the way.
Sorry.
Okay.
Yeah, okay.
I use that joke every year. No one ever gets me anything. I'm so sad. Just kidding. Okay, yeah. Quiet.
Don't ever say it's a joke. Maybe we'll get you something. Yeah, maybe.
Yeah, seriously, I don't want anything.
Oh, geez.
Yep. The other class is working right now, just to let you know.
Good for the other class.
No, they just be quiet and listen.
No.
That's the difference.
Well, they are a different class.
So that means you even have more
We're
homework.
not in that class, so I think it's.
I'll just stop and wait. So we have different size squares. There's two ways of doing this. Okay, number one, if we go from a large 1 centimeter size to a 0.5 centimeters, we're reducing it. So if we draw the same object with the same number of squares in it, it's reduced in size because our square size is smaller. Go and draw that, please. As well, if we keep the same number of squares, but our squares are now larger, it becomes an enlargement. So if I start with 1 centimeter, I can enlarge or reduce using different size grid paper. You should be able to do that for some of your questions for your homework. So if we go from 1 to 2 centimeters, please find the scale factor. Doing new over original. Your scale factor would be 2. Okay. So this would be new, and that would be original. Please do that for the next 3. Find the scale factors for the different possible scenarios. Okay, so there's the 4 different scale factors that are possible for this. When you're looking in your homework, find the scale factor, match it with the paper size that you need to use. Okay. Questions? Okay. Now our last method, we're still using grid paper, but now it's going to be the same size grid paper. So what would you do is you'd have to find new measurements. So we're going to start by drawing a 3 by 4 rectangle, please. So there's 3 by 4. It doesn't matter if you have it going the other direction. What we want to do now for A is use a scale factor of 0.5. So 4 times 0.5, 3 times 0.5. Get your new measurements and draw your diagram. Maybe I'll draw it right about here. Okay. The 4 measurement changes to a 2, and the 3 into 1.5. So now your rectangle should reflect that, and it should be 2 by 1.5. Notice you don't have to be on the grid lines. Look at my A rectangle. Okay, 1.5 is going to be in the middle. Okay, now for B, you're going to do the same thing, except from your original of 4 and 3, you have to find your new measurements. So please do some math to find your new measurements and then draw it. Go. And so now you're going to multiply by 2 to get 8 by 6. So you're going to then go and draw that. 2, 4, 6, 2, 4, 6, 8. Okay. And so you'll have 8 centimeters up top by 6 centimeters below. And this one was 3 by 1.5. Any questions? Yep, Sarah? Oh, sorry. I screwed up here. This should be 2 across. 2 across by 1.5 down. Thanks. Okay. For today's answers, you'll use the grid paper on the next page. You're going to have to look at reference points. So for the letter M, you can do same size grid, or you could also do it on different grid. But you'll need reference points. So for example, how far across is it here? How far across is it the entire way? How far from the side to the middle? All right, use reference points. How tall should it be? Okay, so you need to use reference points. And you should do almost every drawing 2 different ways. Not all of them should be on grid paper. Most, I believe all your drawings will be, though. You have to measure things. For example, the canoe. You have to measure the canoes to get measurements to find the scale factor. The sun. You have to measure the glasses on the sun. Maybe measure the heights of the smile. Measure the diameter of the sun to see if they're truly reductions or enlargements. Okay, get on your homework. Go.